All right, lesson 10.2, we now get to see logarithms. Logarithms are going to allow us to solve for powers, and they also deal with inverses of exponentials. So one of the key things is something like 22. We have an exponential equation, 3 to the third equals 27. We're going to switch forms. That is going to help us later on, not only in this lesson, but the chapter. The base of the exponential is a 3. So that's also going to become the base of our logarithm. Log base 3. The power goes on the other side of the equal sign. So that should be log base 3 equals 3 on the other side. And then what's left over, the 27, goes with the log. So 3 to the third equals 27 becomes log base 3 of 27 is 3. Putting our car basically in reverse, number 28, I have a logarithm. I'm going to write it as an exponential. The base of the log is 13, so that becomes the base of my exponential. The power is on the other side of the equal sign, and then equals 169. Something like 28 provides a nice and easy check. Does 13 squared really equal 169? It does, so now I know I've done it correctly. Using that idea of switching forms allows us to tackle 36 and 38. With 36, we're trying to figure out log base 9 of 243 equals something. We just have to figure out what the something is. So to do that, I'm going to switch into exponential form. It becomes 9 to the y equals 243. Now, if you try powers of 9, you can't get 243. However, if I switch 9 into 3, so 3 squared gives me 9. Now I have 3 to the 2y equals 243. I can try different powers of 3. What power of 3 gives me 243? It's 3 to the 5th. So I have 3 to the 2y equals 3 to the 5th. Now that's an equation I can solve. Bases are the same, so 2y must equal 5. And that means y equals 5 halves, or 2.5. Along the same line as number 38, log base 3 of 1 over 81 equals something. I need to figure out what the something is. Let's write it as an exponential. Base of the log is 3. Base of the exponential is 3. My power is unknown, and then it equals 1 over 81. Now 3 does go into 81. 3 to the 4th gives me 81. But my goal is 1 over 81. So how can I change that? Well, I can say that 3 to the y equals 3 to the negative 4th. Because 3 to the 4th gives me 81. The negative exponent causes a reciprocal. So my y value would be negative 4. Now, looking for a variable in a different spot. In 47, I have log base 9 of x is equal to 2. I don't know what x is, so let's switch the forms again. Instead of log, let's make it exponential. Base is 9, power is 2, equals x. So by switching the forms, going from log to exponential, you now have an equation that's easy to solve. 9 squared is 81, so x is 81. Last but not least, 54. Same idea as 47. I have a variable trapped inside of a logarithm, so switch forms. Write it as an exponential. 10 would be the base because 10 is the base of the log. 10 to the first equals x squared plus 1. And then I'll solve for x. I'll subtract 1 from both sides, so that gives me 9 equals x squared. And then to go from x squared to x, we'll take the square root. So x would equal both positive and negative 3. Whenever you find a solution, you do want to make sure that when you plug it in, you're not taking the log of a negative number, because that's not going to work. But if I plug in positive 81 and number 47, that's going to be fine. Even if I plug in negative 3 into 54, I'm squaring it, which makes it a positive. So none of my solutions creates the log of a negative number.